Alright guys, welcome back to another video with CiscoNate. So today is pretty large deep dive into a very complicated and nuanced project where we bring a workstation online in a secured environment using 802.1x and MAB and allow that machine to develop from its nascent being to a fully fledged, fully managed workstation. So how do you do that, and how do you do it securely? Let's kind of dive into the theory, the ideas, the mind mapping behind it, and we'll get started here. Let me switch this over. So this is my little whiteboard here. It's quite fantastic. We're going to talk about kind of your typical use cases on a enterprise network. You might have a machine, we'll call it A here, and this machine has no image. It is nothing yet. It plugs into your switch, and that switch says, hey, we're running 802.1x. I need your info. And that machine says, I don't know what you're talking about because it is not configured for 802.1x. When that happens, the switch then, if configured properly, will ultimately end up falling back to MAB, at which point it pushes a policy dictated by ISE upstream. And typically, something like that, you understand this process. You're like, hey, I intend to allow machines to come online and onboard in our network. So you would push a policy like something that says, hey, allow them to talk to NTP, DHCP, my FTP or TFTP servers. Let them talk to my Active Directory. Let them talk to, all of the things that they would need to talk to, including maybe ISE. All right, so you'd push this dynamic ACL, and that dynamic ACL would allow this device to then reach out, pull down some scripts, install some software, and slowly develop its personality. So, okay, that's great. Let's start again. Now we know kind of how that process is going to work. There's a few different ways you go about this. You either connect a machine to your already existing network, or you connect it to, for example, it's already connected and you're re-imaging the machine. And we'll talk about how to kind of go down that path. But let's mind map out what we need now, because it's very important to understand each and every piece of technology in your build. Building something like this, even if you have separate teams, somebody who's responsible for platforms and are supposedly experts in that field, and somebody who does the infrastructure and maintains your AD and DHCP and all that stuff. You got security guys who maintain ISE and develop policies. You got the workstation guys that build the gold images. All of these pieces fit together like Legos, and they are highly reliant on each other if you want to be efficient and effective. But that also means it can be brought down by any one of those single pieces being misconfigured. This is why I see it as very important to build all of these components myself, so I run into any pitfalls that quite commonly can happen. I also see it as very important because we're all still always learning. I am always learning. And that means you have to understand that people on your team are also always learning. And even though they may be responsible for those components, it is very likely that they will and can make mistakes, either through just inexperience or through somebody leaving and a new person joining the team. They just haven't gotten that experience yet. There's a whole lot of reasons, but we have to be cognizant that that is possible and try to help each other where we can. And so that's why these videos are developed the way they are. All right, so that aside, let's talk about all of the technologies involved here. Number one is you have a machine. It's going to do MAB. You have to have your switches configured for 802.1x and MAB and have something controlling that policy, ostensibly Cisco's Identity Services Engine in this case. You also have DHCP, and that is running typically on your domain controllers or a Linux head end, whatever you've got. But one important thing about this whole process is when a machine boots and does not have a personality yet, it can do what's called PXE boot. So it looks through, says, hey, I don't have any disks to load from. I don't have a CD in my drive. I don't have a USB with a bootable image. Let's PXE boot. And PXE boot is a very old technology at this point. There are now standard iPXE, which is just like a beefed up version of PXE. It can support HTTP and a few other protocols that are much faster and much more effective. But on some machines, like my ESX 7.0.3 environment, only PXE is available. So, I know I have PXE. My goal is to build this machine as fast as possible, while maintaining the agility to change and reconfigure it on the fly, and that will influence the end design later. This will likely feel like you're flying an A380 through a hula hoop, and it will take time and iterations to get it right. When you PXE boot, you send out a DHCP discover as the NIC stack initializes. That DHCP discover hits your DHCP server. And what's interesting about this is embedded in that DHCP discover is a field, and that field will say something like PXE client. That is the vendor class ID embedded in the DHCP discover, and that is very important because you can take a machine and now definitively say, well, at least I know it is purporting to be a PXE client and needs some information. I can trust it enough to give it access to only the resources that an actual PXE client would need. So on the back end, you tell ISE to push an ACL when something's mabbing, and to push an ACL that allows it to talk to AD, TFTP or FTP, as we discussed earlier, all of those things, right? So ad nauseum, you got a DACL. In addition, you tell your DHCP server to send options 66 and 67. And what are those? Well, 66 is the boot server or file server. And 67 is the actual boot file. And it's a boot file including the path. So for example, in my environment, 192.168.30.40 is, or 41, is my TFTP server. TFTP is only possible with PXE. And then I have the file that I need inside the PXE directory. And the file is SNMP only.efi. So then it takes that image, it boots it, and now it's using iPXE. And I'm going to go down this path in my environment here, but I think we're going to stop here and start jumping into the practical look and discussion of this. So let me close this up here real quick. First, we'll take a look at my domain controller. And I was telling you earlier about how that traffic looks, but I think it's better if I show you practically what it looks like. So Control F, PXE client. So if you go onto your Active Directory server running DHCP, if you do, under the Windows System 32 DHCP folder will be a running log of client DHCP discovers and responses. And what you can see here is here's my Windows client from previous builds when I used it, sending out PXE client as its vendor class ID. And this is fantastic because I need that info so that I know what stage it's in to apply the appropriate and dynamic policy. So then if I come down to my actual DHCP server configuration, you can see that I have a policy that says if I see it's a PXE client, return that server that we talked about and this EFI file. Now there's probably two things that you recognize here if you're pretty sharp, and that is, number one, what's a policy, and number two, why is that called SNMP only.efi, and why is that what you chose? And I've got some files to help out. So first off, what is a policy? A policy is a dynamic way of handing out these options. You don't want to send PXE boot options to machines that aren't PXE and aren't PXE booting. That would be a waste. It would also send out extra info you don't need to. So what you do is you create a policy. And the way you build this policy is essentially like every other policy, even in ISE. It's if this, then this. So in this case, I say if the vendor class equals PXE client, send option 66 and 67, which you saw earlier. Now, on many servers, this is a Windows 2022 server, these options, the vendor class ID, do not necessarily exist. So this is something you or the guys running your environment may not know, and you say, hey, I need you to create a policy looking for this vendor class ID. In order to do that, you have to right-click on the server, the IPv4, and say define vendor class. And you can see here I already did this, but this is just for you to be able to follow it up. You create the policy, name it whatever you want, and then you put in the ASCII that you need to match. In this case, PXE client. So that's how you create the vendor class ID, and then the policy, which says send these out whenever I see that. That's part one. Second part is, how did I arrive at SNMP only? And that is through a very complicated decision tree that I learned on the fly. So I'm going to go to this decision tree right here. And you will have access to this. All of these resources, every one of those files you just saw blink on the screen and then they go away, will be in the Google Drive. You need to determine whether you're booting into BIOS or UEFI first. And if you're BIOS, you'll be using kpxe, .0 or PXE, and if you're UEFI, you'll be using .EFI. I am using UEFI. Now, if you are using a PXE boot or ipxe script, even though you're using EFI, you will have to turn Secure Boot off. Secure Boot checks to see if this is a signed package. None of the PXE or ipxe images that you can download from the internet are signed. So you must turn that off unless you go through the trouble of signing your own, and then you have a whole another bunch of trouble where you have to add the certificate chain to get it trusted and everything else. So bottom line, if you're labbing, EFI, Secure Boot off. If you're looking to use ipxe, then you have to figure out which version you need to use instead of the standard PXE. And in this case, we are chain loading because many modern systems, boot systems, now include ipxe by default. Ours does not, and it cannot because it's part of ESX. So we are loading PXE first and telling it to go grab the ipxe, in which case we're going to select the correct ipxe binary. How do you know what is correct? This is a large learning experience for your environment, but again, every detail matters. What you'll find is ipxe comes in a fully baked package, which has the native drivers, i.e. for the NIC, already included in it, but these are not necessarily compatible with each and every system. And the other one uses the firmware network driver, the one that's built into whatever you're using. In this case, I'm using a PCIe pass-through card that has what's called a ROM on it. That ROM has its own drivers for that PCI pass-through. So that's what we're going to use. That's how I arrived at SNMP only. And then you have to worry about the architecture and everything else. So all of this is here. It's for you. It will be in the share drive. So that aside, there is one additional minor step that I need to tell you guys. And that is that essentially when you load ipxe, it needs to know what to do next. It knows it's there just to help. And it has this tiered process of looking for autoexec.ipxe in the directory you just pulled the ipxe EFI from. And so it will look in that directory. And if you have that autoexec there, it will use it. Otherwise, it will look internally for a script that you've pre-placed. And then that's it. And then it'll look at, the previous directory. And that's it. So you have to either embed the script to kickstart this process, or you have to have it hosted in the directory that you already had. Now, part of my problem is I could not point it to a new directory, and I didn't want to have a bunch of stuff over TFTP. That was the whole point of me loading ipxe in the first place. So what I did, and what you will likely have to do, is open up your SNMP EFI and repackage it with the autoexec built into it. So to do that, I've got another walkthrough page that will show you how this works. It is not hard. Because I run Windows for most of this, I went ahead and used the built-in Windows subsystem for Linux. When you do this, don't make that mistake I just did. You want to run it as admin. When you run it as admin, then you're going to update the apt. You're going to download the build essential.git and install it. Then you're going to clone ipxe. And you're going to go into the source directory. And you're going to create this file. Now, one thing I hadn't talked about yet is there are scripts within PXE and ipxe, and there's scripts all over the place, whether you're in Windows or not. But all these scripts do is tell it, well, what are you going to do next? So the best way to have this automatically just work out of the box is to tell it to reach out to my FTP server or HTTP server and pull down the next script. And why would I want to do that? Why would I want to go from one script to another? Well, the point is, this is just like the shim script. It points it to the other script. And the reason is so that I can change the Boot.ipxe you see here at any time to change this flow, to make it do something different. I did not want to have to rip open and repackage this ipxe script or ipxe EFI every time I wanted to change something, right? That's just very intrusive versus just updating a text script. So this was a shim script I created by doing this exactly once I was in the ipxe source directory, and then I compile the SNMP EFI and include that script in it, and then you can access that directory through a hidden or internal Windows share through Explorer, which will allow you to then grab it and pre-place it in the proper location, your TFTP server. So that's it. That's what I had to do. It's what you may also likely have to do, and it's built in. WSL is built into most Windows servers, Windows home computers as well. You just need to tell it to add that feature. Add or remove programs, add that feature, WSL. Okay, so we've talked at length about the DHCP options, SNMP only, and why that's important in this particular build. Again, every facet matters here. And then compiling the autoexec to tell it what to do next. Let's take a look at what those files do. So I've got the autoexec. Now you may have seen it in that other file, but basically it tells it just DHCP, get an address, and then reach out to the server. One thing I highly recommend is when you guys are writing these scripts, you do exactly this. You print a I'm starting this script line, and then you always have a failure pop out. And you want that failure pop out to then print a message saying I failed and freeze on the shell. If you don't drop the shell, this error message will print and it will close immediately. And you will never see why it closed or what happened or where it stopped, right? If you have multiple of these. So this is highly recommended format here. Do what you want to do. If you fail, jump to failed, print a message, and drop to shell. Hold that window open so you can see it. Now, autoexec just tells it to go grab boot. What does boot do? Boot tells it to get an address again, sets the base to the directory where I have all of my Windows PE files. Windows PE is a RAM-only, like mini Windows that runs with some Windows capability to install the real Windows that you actually want to run. It's a miniaturized environment. It's called Windows Pre-Execution Environment or something like a pre-boot environment, PE. And it's about 300 megs by default. It can mount remote SMB shares by default. If you want to use HTTP for any reason, you must add PowerShell. And I did that because in this particular environment, my core tenets was to be fast and be flexible. And one of the end state goals, as we discussed earlier, is to have it pre-install the CCM, Mecum client. And in order to do that, to get the latest one always, so I don't have to keep updating manually the scripts or which version lives in a drive, is just go fetch it directly from Mecum. And Mecum does not like to Windows share that directory. It hosts it, however, through HTTP very easily. So we need HTTP. Hence, I have to rip open this WinPE image and bundle PowerShell into it. So how did I do that? Well, another PDF file here, WinPE customization, walks you through how you can do that the same as I did. The first step is to download the Windows PE media. And there's no real media. What you actually have to do is download and install the Windows ADK, Administrative Assessment and Development Kit. So you install the ADK itself, and then you install the WinPE add-on. Now, one gotcha you might run into, which I did, was I installed this like 2 years ago. And when I went to go install the latest one just now to do this again, it kept telling me, hey, you need to install the Windows ADK first. which was weird because I was installing the Windows ADK. Suffice to say, I had to go uninstall the old one entirely and then go install this new one, and it worked perfectly fine. You install the ADK, you install the WinPE add-on, and then you go about following the rest of this guide. You copy the media for the AMD 64 version. It depends on your environment. I had AMD 64. Then you open it with DISM. You mount it with DISM, and that allows you to install the packages to do things like PowerShell. Now, this Win pre-boot environment also, as we described in our walkthrough earlier, must launch Startnet.cmd, and that Startnet.cmd must be in a particular directory to start with. That is this file right here. And all this does is launch WinPE when it's in the right directory, turns on maximum power mode so it doesn't automatically or accidentally sleep or disable NICs or anything else, because that will cause problems. This is a virtual environment. Yours may be hardware. It has a stall ping where it pings 10 times just to wait for the NICs to initialize, and then it uses the NIC to remotely mount the share where my Windows 11 boot images are. I copy a bunch of other necessary files that we talked about earlier, how they chain to each other, and then I run the deploy that I copied over. And what does deploy do? What does it look like? We'll go ahead and pull that up as well. Now again, this file had to be added, embedded into the WinPE when we were following this step here to do PowerShell. We do this, and then we add the Startnet in the Windows System 32 directory, and then you close or unmount the image, and now that image has that built in. So I didn't want to have to keep modifying the stuff where I have to like intrusively rip open, repackage, and close up again. So these were meant to be just shims that reach out and launch the rest of the stuff in case I wanted to change the rest of that stuff, which I did iteratively quite a bit. So what does Deploy.cmd do? This is the real meat and potatoes of the whole build. It looks at the disk, makes sure I have my partition file, and then it partitions the disk. After it partitions the disk, DISM installs over that remote share I mounted the actual 5.6 gigabyte boot image. Now I had a comment here saying attempt to speed this up with ipxe IE using HTTP. Turns out that the SMB share is just about as fast as HTTP. It offers no real performance advantage, so it was much easier just to leave it as a DISM remote share install. I then also took the Unattend file that I talked about earlier, and that Unattend file, let's take a look at it. That Unattend file sets the environment locale info. It sets up credentials and tells it to join the security lab domain automatically. Then it sets local administrator password and local administrator credentials. And the most important part are these two lines down here, but this whole segment is also very good, is skipping the OOBE. That way it doesn't stop and ask you, hey, do you have one keyboard? Is it English? Is it Dvorak? Is it whatever? It gets rid of all that auto prompting. So you have a seamless instant start. Now your platforms guys probably know this, but just in case, you now have a template. After it copies that file, it shoves it into the 3 most common directories, because Windows has not been consistent about this, and that is the Windows Panther directory, the Windows System 32 sysprep directory, and then the root directory, the X drive of that image. After I copy the file, I check to see if at least one of those succeeded, and I consider it good if at least one did. All 3 should always succeed, because I create the directories ahead of time as well. I then have a shim in here to install drivers if you have them. And then the last 2 important steps is that I copy Mecum CCM client directly from the server. And this is the line here. If you need to change it, this is the server, this is the default share, and then CCM setup is always the client. It goes ahead and downloads these, and if it successfully downloads it, then copies it to the directory. The last thing it does is it pre-places the setupcomplete.cmd file, which will then run and install and configure the CCM client once the Windows has joined the domain and fully booted up properly. Setup complete. And it puts that in the proper directory, which is Windows setup scripts setup complete. Windows, when you build it, will always run the file in this directory. if it exists. And last thing I do is create the boot entries and boot into your new Windows 11. So that's it. That's the whole chain of dependencies and configuration there. That is how it works, and it works well. You just have to have all the correct files there. So let's go take a look at the other side of this. Now, I told you earlier that you would need Identity Services Engine to push appropriate policy. And this is an important part of the whole build, is to minimize your risk, your accessibility, while this machine has the privileges to still boot the way you intend it to. So if we come into here, I've got a policy set called NSO, and this is where all of the devices in the NSO city live. And when I boot it up, that machine is going to fail, and eventually it's going to fall back to MAB. So I've got a authentication policy which allows MAB, as long as it's an internal endpoint. And then it will bucket it saying if it uses MAB, then apply the NSO onboarding profile. Well, what does that mean? Let's go take a look. We'll come down here, go to Policy Elements Results. Wait while it loads. And we'll come down to Authorization Profiles. We'll go find the NSO onboarding profile. And we'll see that ultimately it pushes the NSO onboarding ACL, or DACL, Dynamic ACL, the VLAN 600, which is the machine VLAN, and tells it to reauth every 900 seconds. That's great. What is this ACL? Or where do you define it? Come down here, NSO onboarding, and you'll see that it's everything I talked about earlier. It's an ACL that allows DHCP, it allows TFTP, SMB, HTTPS, and HTTP to both of our NAS IP addresses. Then it allows DNS to our DNS servers. It allows communication to ISE servers. It allows MECM server. It allows Active Directory servers, and then some of our security apparatus, things like Tenable and other things. But the point is, it can't talk to everything on a network. It can only talk to these few things, and these few things which are necessary to get it online and healthy. So let's go back then. We've got our ACL, we've got our policy. What happens when it starts growing and evolving? Well, when it sends that DHCP PXE client, the switch is going to send that information to me, to ISE, and ISE is going to say, oh, well, hey, this thing's not just an unknown mapping anymore, it's now a PXE client, and it will switch the policy to NSO onboarding 2. Now, in this case, that doesn't really do anything. NSO onboarding 2 and onboarding both push the same policy. But the point is to demonstrate that you can have very discrete control to change behavior. But there's one rub here, and that is, how do you detect it's a PXE client? And this is something I had to build with my understanding of everything that's happening so far, and it's something you will likely have to build out as well. All of the buttons are there. You just have to kind of figure out how to use them. So let's go take a look at profiling now. If we look at profiling, profiling works much the way you and I do identifying anybody else on the street. We use attributes we're familiar with, and the more of the attributes we are familiar with and that we see, the more confident we are, or the more certain we are that this thing is what we think it is. Right? It's just like you can see anything on the road and understand it's a car because it has some common attributes. You may not know it's a Hyundai Elantra or a Chevy Cobalt, but you know it's a car. And it's all these other details like the Chevy symbol that tells you it's a Chevy. And then it's Cobalt because you can see a certain make or model part of the car. You get the idea. So if we come down here, we're going to go look for our PXE client profile. I'm going to filter just kind of plain text. Here it is. So I can see the condition is, hey, if it's a PXE boot, increase the certainty factor by 40. And as long as I hit 10, it gets bucketed as a PXE client. You might say, well, what is this PXE boot condition? That's a good question. Let's go take a look. If we go to our work centers here, and we go down to the policy elements under profiler, here's the profiler conditions. So let me go pull up that PXE condition. Now, I told you earlier that understanding each and every aspect of the technology is very important. This is where it is extremely important, where it shines. You can see the DHCP class identifier starts with PXE client. That's the same value we used for our policy in our DHCP server. This is how we're determining that this machine has changed. And again, all of that information is sent as long as you have 802.1x correctly configured on your switch. So let's go take a look at this in action, live, like the whole thing works. And I already described how we go from PXE to Boot.ipxe. ipxe runs a bunch of scripts and loads WinPE in RAM. WinPE through that file I showed you, Startnet.cmd and Deploy.cmd, then formats the drive, installs the Windows 11 image using that dism command, downloads the Mecum CCM client, and then sets up a script to run it and the unattend file to run when that machine then boots, and then we boot it. And it goes through all of that. So let's take a look at how that actually practically looks, and let's watch what's happening from the vantage point of everything else that can see it. So I'm going to, in my Identity Services engine, I'm going to go ahead and switch over to what's called Operations Radius Live Logs. And then on the switch, I'm going to be sitting here running show authentication session int GI103 detail. And you see there's nothing on this port right now because this machine, even though it's quote turned on, it's not actually booted yet. Now this is the one thing I could not get streamlined in ESX after all the work I've done, and it turns out it's simply because it looks for valid boot drives or boot possibilities before the PCI NIC fully initializes. And there is no trick in the books that you can use to tell it to wait for the PCI ROM to initialize and present itself. So you always end up at this screen, no matter what trick you use. I know there's a lot of boot delays and things like that. It does not work for this specific use case. If you click in here and just hit enter, it'll work for the VM. Now on physical machines, this will not be a problem. It would just start. But on the VM, that has to happen. Now if we come here, at some point, we should start seeing a machine, and you can see, hey, look, it already bounced to MAB, and that is fantastic. Now, the reason it moved to MAB so fast is because I tweaked this configuration, and you would likely do this too in production. I allow it to use MAB. It goes 802.1x first, but I tweaked this down so that it allows 3 seconds for the retries. And that way, it doesn't sit here ridiculously long and cause PXE and ipxe to time out first. So you can see here it says starting embedded ipxe script. That means that that script I embedded with those instructions in the PDF I showed you are running. This is great. I have a visual indication and can see that my intent is working properly. Now if we look on the switch, nothing has really changed. It's still going through MAB because it's still PXE. Let's take a look at ISE. If we take a look at ISE here and I refresh so that I see the most recent authentications, here's my current box. And what will be important about this is if things work properly, you see it's currently identified as a wired, MAB, and NSO device onboarding, right? So it's applying my NSO device onboarding, and you notice it identified as a PXE client. This is perfect. This is what I wanted. Initially it mabbed and it was NSO mab build, NSO onboarding ACL1, and you can see it immediately profiled once PXE started and got pushed into NSO device onboarding policy and applied the NSO onboarding DACL 2. This shows you that ISE dynamically and instantaneously changed privileged access for this machine. Now the rest of this is going to take a long time. It's going to boot into Windows PE, and I'm going to leave ISE kind of off the screen here because really, once you configure right, it's kind of boring. So it's just going to sit here in NSO onboarding as a PXE client until all of this is done and it reboots into Windows and the NIC presents itself. So what we're going to see here is the Startnet.cmd that I embedded into the WinPE environment. Here's the 10 ping stall so that the NIC can properly initialize. And then you'll see everything else very verbosely so that we know what step it's on and what stage it's in the boot. At this point, PXE has reached out, pulled down the ipxe. ipxe ran its autoexec.ipxe. Autoexec.ipxe told it to pull down the boot.ipxe. The boot.ipxe told it to load Windows PE. Windows PE has loaded and Startnet.cmd is running. You can see it just copied all of those important files and it's getting ready to execute Deploy.cmd. and Deploy.cmd is now running. It partitioned the disk, and it's now hit the line where it is configuring and installing the actual Windows file. So let's go look at our deploy real quick so you can kind of mentally keep track of roughly where we are. We are at this step right here, where we are now applying over the remote share the Windows 11 image. Now this is going to take a while, so I'm going to leave this running and then probably edit or cut this out, and we'll jump back to how it looks. Hey guys, welcome back. So I figured I would jump into this right as the image finished. You can see it applied the image. It printed a bunch of messages from the Deploy.cmd right as it finished. So that is, let's go back just so you guys are following along. You can see here it didn't take too long, 10:34 now. And so you can see it printed all of these finished lines here, copied XML to at least one location. So we are right about here. And then you saw the blue line was it fetching with PowerShell, the CCM client. We'll see what happens here in a minute. We should see some more diagnostic output soon. So this was the last output line we have. This is how we track kind of where we are. Now, one other thing I wanted to chat about too while we have a minute here is I went over explaining exactly how I created these files. You would have somewhat passively understood how it's working once you look at all of my scripts and what they say in them. But what I wanted to show you was on the server side where I hosted this via TFTP, web, and through a share. This is what it looks like. So for TFTP, under the PXE drive, this is the first PXE boot that I showed you, SNMP only EFI. Once that loads, it points at the web share ipxe and tells it to boot the Boot.ipxe after autoexec, and then it uses this WinPE to download the images. Now this was the images I was talking about earlier when I said I had to kind of rip it apart, put my own stuff in, and then bundle it back together. These are the necessary files that you will need to place here. The BCD, the boot.sdi, boot.mgfw.efi, boot.wim, and wimboot. This is what's necessary to load and run WinPE. Now you shouldn't have to worry about this too much. Typically it would be, I think your platform's guy's doing this, but here's the idea. And if you have any questions, you can post them in the comments. The last thing is once that WinPE is running, it loads up the Win11 boot sources directory and applies only one single image, and that is the boot.wim. Install.wim. This is the 5.6 gigabyte file, 5.4549. So install.wim is the universal image. Now you might be asking yourself, well, why is there all these other directories and all these other files? It's because the Windows 11 boot media was meant to be an essential one-stop shop for installing on any system, like any system. And so they have a ton of files that you will not necessarily always use. There's also like 15 different ways to do each and everything I've shown you today. So it will be custom to your environment. It is not going to be the same for everybody. Just wanted to throw that out there so nobody's wondering why I have stuff that looks different. You guys will all find your own way, but the strategy and the decision trees provided here will help you make those decisions for your environment. Okay, man, yeah, this sometimes can take a while. Oh, there we go. Setup complete, copied, CCM setup, boot entries. Fantastic. And here we are. It has written those to disk. And you know, earlier, the very first time I loaded this in, it said skipping the drives and then went to network boot. This time it restarted and it went straight to the drive because it has a valid bootable disk image. And this is it. This step right here is going to take like 20 minutes. It will start up the NIC. It will, again, MAB because it doesn't have the GPO until it finishes the domain join and all of that. But once it's online, the unattend will tell it, join the domain, configure user, skip out of box experience, OOBE. When that happens, it will then get a GPO, pull down certs, it will configure 802.1x, and you will see that flip in both ISE in terms of the profile. Will now show Windows 11. It will also be able to run 802.1x, so you'll see it suddenly start jumping over to 802.1x. Show auth session NGI 103. And I think that step takes a while because it needs to join and pull down GPO and stuff, and the NICs need to start. So you're not going to see it now. But this step here will take about probably 15-20 minutes. After that, it's a fully baked, fully domain joined machine. So I think I'm going to wrap up with that, guys. This was enjoyable. You guys have a good one, and good luck on building your Windows environment dynamically while still securing it with 802.1x and ISE.